I'm going to show you here a quick recipe that I figured out on how to make custom threads. I've tried to use a different method to do it with solid bodies, and it's far easier to use it or produce it using surfaces. So let me show you that here now. We have the front of your part. I'm looking to design a part that rotates around the z-axis. So I'm going to put my thread profile on this plane here. Threads are defined by the OD of the male thread, the major OD of the male thread, not including tolerance. This part that I'm trying to produce is 3.5-inch diameter. I'll divide that by 2 to get the radius. I will then draw. This part is also a 7-pitch thread item, so 1/7 of an inch, and that should also be a sketched component. And it's actually a sheet metal thread in my part. So I'm going to divide up this in half. I'm going to give this the thread engagement of 0.035, 3.5 hundredths of an inch. And I'm going to use these here. I'm going to actually continue that on and continue this on just for tangency. I'm going to mate that with those dimensions just because, really. Doesn't have to be. These are not sketch lines now. And they are like that. Now I also need this to be, let's see here, I need that to be tangent to that. And that appears to be tangent to that. Then I'm going to put a dimension there and define it as half of that. And this to this as that divided by 2. Now I still have the issue of that. So I'm going to define this one as that divided by 4 because it's 1/4 the distance. And this should now be it's not a sinusoid, but you can tell what I'm doing there, I'm sure. So this right here should have been on that right there. I'll just make a sketch line and give that horizontal. So now I have a thread profile that is on this radius. I'm going to take that. I'm going to, in a second sketch, I just want to lay out for myself that project P. That point right there is the radius, and I'll lay a circle on it, which is also a sketched circle. It's a sketch line, not a a construction line, not a regular line. Just for my own senses, I'm going to go to coil. I'm going to make it on that surface there, and I'm going to define that coil. Yeah, I keep hitting escape. I shouldn't. I'm going to produce it here on that there. And I'm going to define that as D1, which should be the first, well, times 2. D1 times asterisk 2. That is the diameter of my circle, 3.5 inch. I'm going to make that 0.01 of an inch triangle. And this doesn't exactly matter that there is not a sketch line on my diameter. You'll see what I'll do here in a second. So I produce that. Now you have to produce 1/2 of the thread. This is assuming that this is a single lead thread and there's not 3 threads at 120-degree phasing or something of the like. Single lead thread. I'm sure if you're smart enough to handle multi-lead thread, you can figure out how you have to manipulate the numbers to do something else. But for simple single lead thread, I'm going to do 1/2 of rotation, pitch. Again, I said earlier this is 1/7 of an inch, it's actually 7 pitch. There's 7, no, excuse me, 1/7 for every rotation. 1/7 of an inch is the progression. No angle, triangular, internal, on center works good. A small section size, I don't know that it necessarily matters, but it helps. And again, this is my diameter of the circle, which is the same as this exact point right here's diameter. So we're going to produce that. We're going to go move. We're going to select that body and translate. We're actually going to use origin point. We're going to create a copy from, let's see here, from that point, that right there, and then, well, I actually don't have one there, so I'll just switch since I can. I'll use that one and that one. It simply elevates the part, well, exactly 1/7 of an inch in elevation. So I could have just entered that in as a number in the Z as well. Doesn't matter. This gets me the same result. Again, create copy. You want 2 of these half spirals, half coils, which are a thread profile. You're going to create it, go to surfaces, create sweep profile. That's my entire profile, 1/7 of an inch tall, 0.035 thread engagement, assuming it's got no tolerance at all in the thread engagement. First path is that one. Second path is, well, the guide rail is, I don't think that's right. Nope, it's that one. There you go. There's 1/2 of one thread surface to start with. Now, make sure it's not you. I don't think it usually defaults to full extents, but here it is. Here is the reason. This was the major flaw I had. If you do not select full extents, you see this angle here where it's not perfectly planar on like the origin plane. That will cause all the problems in the world for you. You must have it to full extents. So there's full extents, 1/2 of a thread. From here, it's pretty easy. We'll do move. I'll actually first remove the coil bodies, which I do not need anymore. I do not have any downstream references. Excuse me, I need to remove at this point in time. There we go. Remove. Maybe I hit delete before. So, move, bodies, select entirely. We're going to do, just going to first copy, elevate, rotate about the Z, 180. And then go point to point origin. And we're going to move that point to that point. And now if everything has been done right, the corner here and the corner of here are technically the same exact point in space. That one right there. It's pretty easy sailing from here on out. First, let's do a stitch of these 2 bodies. It should be perfect. Accept. Move. Actually, we're going to do an array or pattern, rectangular pattern. Grab that on the Z axis. We're going to do, I'm going to do 14. I would like distance 1/7 of an inch. Actually, that's extent or spacing. There we go. 1/7 of an inch. And these should be nice and cleanly lined up. I don't see any overlapping. Looks perfect. And then since my part's rotational phasing does not matter, I'm going to go back to solid here. I cannot save the bottom thread or the bottom first lead of thread or the top lead of thread. I produce more thread than I need and then I trim it back. So I will actually go to construction, offset plane, that plane there. I can go to object, which is that point there. And then from this plane, I actually choose, I'll repeat offset and I'll choose how much of it I want. In this case, I want 1.25 of thread. Select, go back to surfaces, modify, split body with face. And next I actually need to merge all of these separate surface bodies together, and then go back to modify, split body, grab that body, turn off origin. This is the construction plane. I'll do the same split body, split that body with this cutting plane, correct. And then this one I'm going to remove. That one is the very bottom section. I'm going to remove it as well. Now you have a perfectly trimmed, threaded, this is for me a sheet metal retainer, which I could either thicken, or in this case I'm going to make a tool, and it's as simple as a patch. So create a patch on the top diameter, Beautissimo, and another patch on the bottom. Stitch them all, call it a day. And there we go. Turn off the construction planes. And here is our solid body with custom thread profile, which can be changed to a multi-lead thread if you needed to. It can be any thread profile you need, etc. I do not yet have a method to do a tapered threaded profile like this, although I might need to, so I might have to figure out how to do that. But hopefully this helps for your project.